Hello students, welcome to my channel iSmile Academy. Today we'll be doing Electrostatics Part 2. The first question, three equal charges are placed on the three corners of a square. If the force between Q1 and Q2 is F12 and that between Q1 and Q3 is F13, the ratio of magnitudes F12 by F13 is. So first let us draw the diagram. What we have in this case is, so here we draw the diagram, a square. So this is a square. Let the side of the square be R. So everything is R. So we have a square at this point. We have a charge at this point, another charge at this point, and the third is at this point. Let this one be Q1. This is Q2, and this is Q3. Now this distances are R, but this distance, the diagonal, we can calculate the distance of the diagonal by using Pythagoras theorem. So if this is suppose y square is equal to r square plus r square, if we calculate this, what we get is y square is 2r square. So y is then r root 2. So this is actually r root 2. I write it here. Now we find first of all F12. We ignore the negative sign and positive sign. We just write the magnitude. So the force between Q1 and Q2, it is given as 12. Therefore 12 we use Coulomb's law. It is 1 upon 4 pi epsilon 0 Q1 Q2 upon r square. Distance is r square. Then F13 is the force between Q1 and Q3, and the distance is given as r root 2. So F13, we use Coulomb's law here also. So we get 1 upon 4 pi epsilon 0 Q1 Q3 upon, so square is 2r square. So this is 2r square. Now we have to find F12 upon F13. So we just take the ratio F13 by F12. So F12 by F13. So F12 is 1 upon 4 pi epsilon 0 Q1 Q2 upon r square, while F13 is 1 upon 4 pi epsilon 0 Q1 Q3 upon 2r square. Now here one thing is given, all the charges are of equal magnitude. All charges are equal. So it is given three equal charges are placed. So Q1, Q2, Q3 and all are equal. So they cancel out here. We can see here Q1, Q2 gets cancelled with Q1, Q3. 4 pi epsilon 0 also gets cancelled out. R square also gets cancelled out. So what we are left is F12 upon F13 is 1 upon 1 upon 2. So this 2 goes up. So we get answer is 2. So here what the answer we are given is B is the answer in this case. This one. Next is question number 2. Two charges Q1 and Q2 are placed in vacuum at a distance d and the force acting between them is F. If a medium of dielectric constant 4 is introduced around them, the force now will be. So what we are given? We are given two charges. Okay. Let us say these are the two charges. These are the two charges. They are separated by a distance d, small d. So this is Q1, this is Q2. So in this case the force between them is F. Now in the second case they are placed in a medium of dielectric. Let us say this is some dielectric medium. There is a dielectric between them. So this is Q1, this is Q2. The distance is not changed, so it is d only. So here we have some dielectric. So in that case what is the force? So this we have to find. Now we use Coulomb's law. So K is given. In this case K, dielectric constant K is given as 4 for this case. This one I'll just draw a diagram. Okay, this one. So now we first of all use Coulomb's law. So Coulomb's law, it gives F equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square. Now this epsilon 0 is for vacuum. In general, what we have is, in general, actually epsilon, epsilon is this. The actual formula is 1 upon 4 pi epsilon q1 q2 upon r square, but for vacuum k is 1. For vacuum k is 1, so we generally get epsilon 0 here in most of the cases where we are using vacuum or air. But the general formula of F, which is given as F equal to 1 upon 4 pi epsilon q1 q2 upon r square. This is the general formula, but in most of the cases we are using vacuum or air, therefore instead of epsilon we write epsilon 0 k, and k for vacuum and air is 1. So this is what we get. Now according to the given data, this is the force, this is the force between the two charges when they are kept in vacuum. Now in our case, instead of r square, instead of r we are given d, so we directly write that formula. So F, this is for vacuum, 1 upon 4 pi epsilon 0 q1 q2 upon d square. Now in the second case we have a dielectric medium, so of course the force will change. Let us write that as F dash. So F dash is 1 upon 4 pi epsilon, not epsilon 0 because we have some medium, so we will have different value here in this case. So then what we have is q1 q2, distance is not changing, the charges are not changing. Now here epsilon is actually this, I have written the formula here, epsilon is epsilon 0 k. So instead of this epsilon we write epsilon 0 k, so we have 1 upon 4 pi epsilon 0 k q1 q2 upon d square, but k is given as 4, so this what we write is, here we have 1 upon 4 pi epsilon 0 into 4 q1 q2 upon d square. So what we need to find is F dash in terms of F. So we take the ratio F dash by F. So F dash is given this, so I just take this 4 outside, so what we get is 1 upon 4, and the entire term this one, whatever this left, 1 upon 4 pi epsilon 0 q1 q2 by d square, and F we already know, it is 1 upon 4 pi epsilon 0 q1 q2 upon d square. Now these terms both get cancelled out, so what we are left is F dash upon F is 1 by 4. So what we conclude is F dash is F by 4, so it reduces by 4 times. So this is the answer. So in the option we check it, D is the correct answer. F dash, this F by 4 is the correct answer. Next is question number 3. Force of attraction between 2 point charges Q and Q separated by small d meter is Fe. When these charges are placed on two identical spheres of radius r equal to 0.3 d, whose centers are d meter apart, the force of attraction between them is. So what we are given? We are given 2 point charges. So these are the point charges. Let me draw this point charge. This is another point charge. So because it is given force of attraction, so one may be q, other may be minus q. Both are q, actually it should be q and q, and the distance of separation is d. So the force of attraction between them is Fe. Now these charges, they are placed on two identical spheres. So let me draw the sphere. This is one sphere, this is another sphere, and they are identical, means their radius are same. So when this charge q is placed on this sphere, it gets uniformly distributed. So let me write this way. This is uniformly distributed over this sphere, and when this minus q is placed over here, it also gets uniformly distributed, and because their radius are same, the charge distribution is in both cases uniform and equal. Now this distance is given as d, okay, their centers, and the radius, this radius is 0.3 d, and this is radius also 0.3 d. So out of this entire d, this distance, this one, the separation of charge is actually, because this is 0.3 d, this is 0.3 d, so it becomes 0.6 d, and the total distance between the center is d. So the distance of separation is d minus 0.6 d is 0.4 d. So what we observe in this case is that the charges, they are now separated by a distance 0.4 d. Initially they were separated by d, now they are separated by 0.4 d. Okay. So distance of separation becomes less, and in case of Coulomb's law we have f is inversely proportional to the distance, square of distance. So less d, more attraction or repulsion, whatever it is. So in case it is attraction, so here the option what we have is it is greater than fe. Next we come to question number 4. The value of electric permittivity of free space is, so we are given 4 options. So let us write the equation of Coulomb's law. 1 upon 4 pi epsilon 0 q1 q2 upon r square. So we need to find the value of this. So we write this, we just rearrange the equation so that we get 4 pi epsilon 0 here, and this is what we have is q1 q2 upon fr square. Now we just write the units of each given term. So q1 is Coulomb, q2 is also Coulomb, so it becomes Coulomb square. F is in newtons, r in meters, so r square is meter square. So if in the option we see, this is what we have at this point C. So of course this is the answer. So the value of 4 pi epsilon 0 is actually 8.85 into 10 is to minus 12 Coulomb square per Newton meter square. This is the answer. Next is question number 5. Two similar spheres having charges plus q and minus q are kept at a certain distance. F force acts between the two. If in the middle of the two spheres another similar sphere having plus q charge is kept, then it experiences a force in magnitude and direction as. So let us draw the diagram first. So we have here two spheres. This is one sphere, this is another sphere. So they are similar spheres, they are separated by a distance small d, that is small d. So this is the charge is plus q and this is minus q. So the force is an attractive force. So we have 1 upon 4 pi epsilon 0 q upon d square. We are ignoring the negative sign. Actually a negative sign will come here because it is force of attraction. Now we are ignoring that sign. Now what we do is in this case what we do, we introduce another sphere between the two. This is plus q, this is also plus q, and this is minus q. So this distance is same as in previous case. This is d. So this, of course, this distance becomes d by 2, and this also becomes d by 2. Now what is the force acting on this charge plus q? Now see, this charge is introduced between the two. So because these two are positive, so this will repel it. So this, the force direction is in the on our right side, and because here it is minus q, so this plus q will be attracted towards minus q. So there is a force of attraction towards the minus q charge. Okay. So even in the option we see this may be the correct answer. Okay, we do no need to solve further, but we will solve it further because we need to find the magnitude. So how do we find the magnitude? First we find the force because of these two charges, plus and plus. So this F becomes, let F1, so it is 1 upon 4 pi epsilon 0 q square upon this is d by 2, so d by 2 the whole square, but d by 2 it goes up, so what we have is 1 upon 4 pi so this 2 square is actually 4, so what we get is 4 q square upon d square. So we take 4 outside, so what we get 4 into 1 upon 4 pi epsilon 0 q square upon d square, but this is given as f, so this is 4f. Now similarly for f2 also, if you do the calculation, because the distance is same, okay, and the magnitude of charge is also same, so even for f2 we will get the same thing, so f2 is also 4f. So the total sum, the total force acting on that particular charge q is f1 plus f2, which is 4 plus 4 is 8f, and it is the direction is along minus q, so C is the answer in this case, this one. Next is question number 6. Number of electrons in 1 coulomb of charge will be. So now let us take one electron. The charge on the electron E, one electron E is given as 1.6 into 10 raised to minus 19 coulomb. This is the charge on one electron. So if you want to find 1C, so 1C would be equal to, we can just take this E upon 1.6 into 10 raised to minus 9, just cross multiply this 1.6 I have taken below this, so 1C would be equal to E, so 1 upon what we have to take is 1 upon 1.6, if we take it, it is actually 0.625, and this goes up into 10 raised to plus 19e, so this becomes 6.25 into 10 raised to 18 electrons. So this is the answer. So 1 coulomb, so for getting a charge of 1 coulomb, this many number of electrons are required. So here for us this B option is correct.